Hello everyone, welcome back to the another session in Principles of Programming Languages. Let's continue to learn about schema programming language. So in the last video, we were discussed about schema as a functional programming language, and we were discussed about some sort of functions which are supported in schema language. We were discussed about numeric functions and we were discussed about predicate functions. Today, this video will be going to talk about list functions. Fine. So last video we covered up to here numeric functions and predicate functions. This video will be going to cover about list functions. Right. Now let's see about this one. So basically, when we are working with the functions returns a value, right? It's a fundamental thing that we will learn from the third unit itself. Third unit we were discussed about subprogram. Subprograms will be basically have procedure and functions. Procedure will not return a value, whereas function will return a value. The language which I am talking, if the language is supporting functions or having functions inside of it in a program, then that will return a value. Now, list of functions will show you a difference that which value it returns out. Whether it returns the address of the function or it returns the data of the function, or other than these two, is there any possibility that it returns a value? So, these are what three differentiations in the list of functions. Now, concerned to this, we were going to talk about two kind of functions. The one is CAR function and CDR function. Fine. Now, schema programs are interpreted by the function application, which is eval. When applied to a primitive function, eval first evaluates the parameters of the given function. Following on additional examples of the operations of CAR and CDR. The mean of these two are what? When I am using CAR function, it returns the address of the parameter. Basically, parameter address will be what? Function. Fine. If I say data it returns the parameter. I'll just simplify with an example. Let's say plus A and B. If I apply, I can apply most of the functions. Now I am applying list function on this function. So what are list functions? CAR and CDR. Let's say that I am applying CAR function over here. CAR function. The mean of CAR is what? We will return address of this function. Now address of the function, it returns the address of the function. Now address of the function is what? Plus. So address in the sense what? We will be going to take the first parameter. Let's say it can be a function name, it can be a parameter, it can be a something entity which will be stand as a first class entity. So this first class entity will return a value. So the return value is what? Plus over here. If I apply CDR, CDR is what? Will return data. AR is what? Will return address. DR is what? Will return data. Now, in the case of CDR, what will return? Will return AB. Did you understand? So, these are what list functions to return a value. That function will return a value. If you apply CAR, it returns address. That means the first class entity. If I apply CDR, it returns the parameters what are available in the functions. Now, we'll take some examples and we'll see how CAR, CDR will applicable on function. Now, let's say that A comma B, C are my list. A, B, C are the list. When I say A, B, C are the list, basically list contains two things, right? We were discussed in the last video that list contains two things which are autumn and list. Every list whatever you see, that list will have two things into it, which is autumn and list. Autumn is what? It's a single entity. List is what? It's a group of autumns. Let's say A, B, C. Now, A, B, C, individual autumns. I will call A is a autumn, B is a autumn, C is a autumn. If I find A, B, C, then the way how I should call is A is a autumn, B, C are the sub list. This is the way how we have to talk in the schema, or the languages which are said to be interpreted languages, or the languages which said to be pure functional oriented languages. In that languages, we use basically two kind of data structures, autumn and list. Now with these things will be going to apply, these functions will be going to apply list functions. List functions are what? CAR and CDR. Now ABC is what? Your list. Let's say ABC is your list. The list is containing of 3 atoms. Among these 3 atoms, the first class entity which is represented, that will be your function name. B comma C, or the other than first class entity, whichever are there in the list, those are parameters. Now, so what I have said about CAR, it returns the address or the first class entity. So first class entity among these 3 are what? A. So it returns A. Done? Now the second, CAR A, B, C, D. Now what I said, CAR is what? It returns the first class entity. As here first class entity is a sublist, you have to return a sublist. Now that's what returns AB. And the third, CAR of A is an error because A is not a list. List always should be enclosed in the functional parentheses. That point we learned from the Lisp, correct? If I say that it is a list of atoms, list of sublist, if I say something list of function parameters, that list should get enclosed in parentheses. Now, CAR A is not a properly written statement, that's what it throws an error. Now, if I wanted to make this as a valid statement, I have to write something like this. CAR A, it returns A. The reason is what? You have a first class entity. And now look at CDR. CDR is what? Other than first class entity, it returns the parameter. Now CDR, it returns data. Now among ABC, which it returns? I told you other than first class entity. Who is the first class entity? A is the first class entity. Other than A, it returns the value. That is what? BC. It returns BC. Now look at CDR ABCD. It is what? A list. This is what? A list. Now if I am applying a CDR function on it, then it returns CD. Now if I apply CAR over this list, what it returns? AB it returns. Very simple. If it is a CAR function, it returns first class entity. If it is a CDR function, it returns other than first class entity. Now let's look at CDR of A, it throws an error because I said it should be in a parenthesis. So when it is providing this kind of syntax, then it returns what? Parenthesis. So this is what the way of applying list functions over the atoms. Now, so let's see the same thing. This is what the same slide which is repeated. Now let's look at cons. So con is what? It's what other than CAR and CDR will return. Now let's look at cons A. It returns A. Cons ABC, it returns ABC. So you can say something like, in a sense, that inverse of CAR and CDR. So what is CONS? It is inverse of CAR function and CDR function. Now cons empty parenthesis A comma B, it returns empty parenthesis A comma B. So cons ABCD, it returns ABCD. So it is just inverse of CAR and CDR. Now CAR and CDR take a list of a part and cons constructs a new list from a given list parts. The two parameters to cons become the CAR and CDR of the new list. Now cons CAR a list, CDR a list, it returns a list with the same structure and same elements, which is a list. So this is what the usage of cons function. So this is about your list functions. And look at the construction of, we say it as what? Implementation of or else representation of internal structure. If I wanted to represent the internal data structure of cons of A, we will be constructing this kind. Now I'll take an example for the better understanding. Let's see that I wanted to construct cons of A, B, C. Now let's say that I wanted to write a internal representation for this list. Then how I have to write a list? Cons will return A, B, C as an output, right? That's what we learned in the previous slide. Now A is what? It's a atom. It's a atom. So atom will be having a representation something like this, that it is representing A. Now look at this, BC or what? It's a sublist. Now A is pointing to the BC. Now I just take A, it is pointing to B and it is pointing to C. This is what the internal representation of these kind of functions. That's it. This is about list functions of schema. Thank you all.